Hi folks. In this short video, we're going to walk step by step through the process of creating professional quality, high frequency coverage maps, just like the one we are looking at right now. To generate this map, we will use the VOACAP Online for SWL Webapp. Whether you're a shortwave listener, a DXer, or simply curious about how international broadcasters beam their signals across the planet, this guide will give you everything you need to produce impressive broadcast-grade propagation maps right from your web browser. But why would you want a map like this? Well, what you see here is a guide to how a signal might be received across an entire region, or indeed across the globe, at a particular time of day and time of year. It's a colour-coded map that indicates predicted signal strength, representing typical conditions based on long-term data. Okay, let's start building our map. To build realistic coverage maps, you first need accurate broadcast data. That comes from the HFCC operational schedule, the global master list of shortwave broadcast transmissions. Now, you can download the latest schedule directly from the HFCC website, and I'll put the link in the notes below. So here is the homepage of the HFCC website, and what you're going to do is go to Public Data Files and click on that one. That will bring you up to this page. So the file you're looking for is usually the last zip file in the list. So you scroll right down to the bottom to get the most recent operational data from the current broadcasting season. Now for this example, at the time of recording, the file that we're looking for is B25 all x2.zip, which was the B25 operational schedule as of the 31st of January 2026. Now, it's worth checking when you're doing these coverage maps, it's worth checking every now and again to get the latest updated data from this website. So now we're going to click on the latest file, B25 all x2. We're going to double click on that, and it will go into our downloads folder here. We're going to double click again to expand that, and then we get the folder with all our information. Now the one that we're looking for is the B25 all 00.text. That's the current one at the time of this recording. Now, the other information is supporting information we don't really need. It's this one that we need. So we're going to double click on that, and that will open up in a text file for us. So here's our big long text file here, lots of information in it, and it's all in frequency order. Now it's got headings across the top of it there, and some of these we need for VOACAP. So we need the frequency, the start time, the location, the power, the azimuth, the slew of the antenna, and the type of antenna. Now, for the purposes of this tutorial, we're going to build a real-world example. It will be Radio New Zealand Pacific, and we're going to build a coverage map for their transmission on 9465 kilohertz. So, we're going to run down to 9465, which is right there. And we're going through the process of noting the information that we need for VOACAP. So we need the frequency, 9465. We need the start time at 1300 UTC. The end time is at 1700. RAN is the transmitter location, and that is in Rangataiki in the North Island of New Zealand. It's a beautiful part of the world, a farming community there in New Zealand. We need the transmitter power, that is 50 kilowatts. We need the antenna azimuth, which is 325 degrees. We need to know the slew of the antenna. It's at 0 degrees, and so there's no beam offset there, so we don't have to worry too much about that. And then number 148 is the antenna code, and that is for a particular model of antenna which we'll see when we open up VOACAP. Now this is the exact data that VOACAP needs to simulate how Radio New Zealand's signal spreads around the world. Now we're going to head over to our browser and put in voacap.com/SWL, and that'll bring us up to the VOACAP site. And we're going to follow several steps here. The first step is to choose the transmitter site. So we're going to select TXQTH up here on the top left hand corner of the page, and we're going to scroll down here. You'll see the sites are organised by country codes. So we're going to scroll down right to NZL, standing for New Zealand, and there it is there. RAN, Rangataiki. When we select Rangataiki, the reg marker is going to flick over to the North Island of New Zealand. And there it is, over there. Now the blue marker is the receive site or the listener's location. And we can ignore this for the moment. This can be anywhere on the map, it doesn't matter, because these are global maps that we are creating. So we can really place the blue marker wherever we like. VOACAP defaults to the short path predictions, which is over here. S for short path, L for long path. We need to make sure that's on S. That's usually the default setting. Step 2 is to enter the transmitter power. So let's go up here to the top right, and there's a drop-down menu there. We know that it's 50 kilowatts, so we're going to click on that, and we're done there. Next, we're going to click on the antennas button on the right-hand side, just below the power menu, and it pulls out a sliding screen. And if we look under 13M and 11M, you'll see a drop-down menu, and it's got a lot of transmitting antennas, all sorts of different types. Now, we noted down that our antenna type used by Radio New Zealand is 148. And so we're going to scroll up to 148. There he is there. And it's 148 AHR 2/2/1.0. We're going to click on that. And we're going to make sure that the radio button next to it is also clicked, because that will change all these other antenna settings to the one for Radio New Zealand. So we click on that and they all instantly change there. But what does this antenna code actually mean? Well, in plain English, it is a shortwave broadcast curtain antenna, or more technically, a multi-band centre or end-fed curtain antenna array with 2 dipoles per horizontal row and 2 rows vertically, one dipole above the other, so in total 4 dipoles. The bottom antenna row is mounted one wavelength, that's the 1.0, above the ground, possibly using a screen reflector. Now this type of antenna gives a strong forward-facing beam, perfect for long-distance HF broadcasting. Now we scroll down to the receive site there. We're going to change that to a shortwave whip antenna for all the bands. So we'll go up to here. This is usually the default setting. And so we click on the radio button to change it all over to the shortwave whip antenna. Now this represents an average listener's antenna, a portable receiver with a standard whip antenna on top. Broadcasters want to use this setup as it is a very common listening scenario, so it makes it ideal for SWL-focused coverage maps. Now going up to the main screen again, and we're going to click the settings button, which is under the antennas button. So clicking on the settings button there. And there are 2 sections here. One is the general predictions setting, and what we're looking for is the transmitting antenna beam. And we're going to enter here 325. The other settings can remain as is. That's their defaults there. Now underneath that is the coverage area map settings. Now we know that Radio New Zealand is broadcasting on 9465 kilohertz. and that's in the 31 metre band. So we go to the band settings here. It's already set on 31 metre band here, so we'll just leave that there. And we know that it's going to be operating at 1300 UTC. So we want to change this UTC setting here as well to 1300. We're going to keep the range at 1 hour. Okay, so that means for 1300 UTC, it's going to give us a 1 hour propagation snapshot from between 1230 to 1330 UTC. So it'll give you a decent range there. Now everything is ready for the final step. At the bottom of the display, you'll see 10 green buttons there. Now we need to click the big green button under the world map that is marked Signal Strength Map. And after a short calculation, VOACAP will display a full colour propagation map showing the expected signal strength around the world averaged over 15 days of the month. Let's make this screen a little bigger so that you can see the map. We're going to open it up in a new tab. There's our map. Now, on the right hand side you can see the S meter scale, letting you interpret the colour intensity. There are values from 0 up to S9, and any signals stronger than S9 are represented with a plus sign for decibel level, so plus 10, plus 20, plus 30 and so on. The NF at the bottom of the scale represents the receiver's noise floor. So in other words, no signal is being received there when you're in that particular part of the range. So from this you can see exactly where Radio New Zealand's shortwave signal is likely to be heard. Let's have a look at this. In the yellow, orange and red colours, which represent very strong signals up at the top end of the scale, you'll see that you're going to get good coverage there through East Asia and Southeast Asia and parts of Australia. And if you look at the green areas over here that covers Russia and into Northern Europe, you'll see that there's going to be reasonable reception into that area as well. Now we look over here at North America, you can even see that there's some green hitting the west coast of North America. Green is saying, okay, it could be around about a signal strength 6 at the receiver's location. And so that certainly represents quite a workable signal here into the west coast of North America. The further east you move into the USA, you'll see that the signal is getting a bit weaker into those blue tonings down here towards the bottom of the scale. So this gives you a clear broadcaster quality visualization of real world HF propagation. Of course, the other spot here in the middle here is that there's no propagation expected around Brazil or in most of Africa at 1300 UTC on that particular 31 metre band frequency. So by combining the HFCC database with VOACAP Online, you now have the power to create accurate, beautiful, professional-grade shortwave coverage maps, the same kind that broadcasters and engineers use. This method works for any station listed in the HFCC schedule on any frequency anywhere in the world. So I hope you found that informative and useful, and I hope you have fun developing your own coverage maps for different shortwave stations around the world using the VOACAP Online for SWL Webapp.